So guys, this is the part 2. And it says solving quadratic equation by factoring. So you need to factor this, okay? So basically in the previous lesson, everything was factored for us, but now it is not. So then we need to factor this. So factored form is used when we solve a quadratic equations because it gives us zeros. And this zeros is basically your x-intercept, or we can call it roots, or we can call it solution. Okay. So then in this case, write the equation in the form of ax squared plus bx plus c equals 0. Now remember, one side must be 0. If it is not, then move it to the other side, okay? Then you factor it fully, and then you use the zero product property, making one bracket 0, another bracket 0 separately, and this all for the x value, right? So in order for us to do this, solving by factoring it, same as before, you factor this, okay? And I'm not going to go through the factoring in detail. I expect that you know this, and this is why I emphasized in the last unit, without knowing factoring, this unit is going to be quite challenging, okay? So for this, the product is 24, the sum is 10, so the two numbers are 6 and 4. So then this becomes y squared plus 6y plus 4y plus 24 equals 0, and this becomes y and then y plus 6 plus 4 and then y plus 6 as well. So then you have y plus 6 times y plus 4. Now this will be the only example that I actually go through this detail in terms of the factoring. Now then here you can see that we have two brackets. In order for us to solve this, we have to make each of them 0, and then this becomes -6 or -4. Okay, so the only difference is now you just need to factor this. Okay, now then for b, just be careful again when you're factoring it. The common factor has to be done first. So then this becomes 2x squared minus 2x minus 3 equals 0. And when you factor this, this becomes x minus 3, x plus 1 equals 0. Now, when you are solving for an equation in a factored form, do I really care about the 2 at the front? Well, that's not an x, right? That's not x. So I have no interest in it because it won't change anything since the 2 is a fixed value, right? X is the one that changes, and that's why we call it variable, right? So then we have a factored form, then make the two brackets 0, this one 0 as well. So then x equals 3 or -1, okay? Now, hopefully you try these two on your own and see whether you get this. If not, then come to me. But let's actually try this one. So if you take a look at this, I don't think there's any common factors. There may be possibly, if I square root of that, that will be 5. If I square root of that, that will be 3. So also 3x. So if I multiply 2 by these two, then I get actually 30x, which is the same as what's in the middle. So then this is a perfect square trinomial. So we don't have to go through the product of 1 or actually 225. That's actually quite a large number. So then this becomes 3x, right? And then plus 5 squared equals 0. The plus 5 comes from, well, 5 comes from there, and then plus comes from there, okay? Well, then again, this familiar form, we just need to make this one 0. So 3x plus 5 equals 0. So then -5 minus 5. 3x equals -5. And divide everything by 3. So then this becomes x equals -5 over 3. So that is your solution to this one. And we just did it by factoring it, right? Now, then same thing for D. Is there a common factor? Yes, there is, which is then 6p. So it will be p minus 3 equals 0. Now, then we don't have to worry about the 6, but we need to worry about the p. So what I'm going to do is I'll just put the brackets around the 6p, since it's just sitting alone outside on its own, no other numbers attached as a addition or subtraction. So then you either make this one 0 or make this one 0, right? Now 6p equals 0, well, that is basically 0, right, for the p. and then p minus 3 equals 0, so p is then 3. So your p-value then will be 0 or 3. Okay, so again, factoring is important, and this is one of the reasons why, and why we're solving for x in quadratic formula is because there are a lot of, in real life applications where, for example, you're solving a number of tickets for the concert and you need to know where or how many seats that you have to choose, and usually it works in a parabolic graph. So that's why, okay? And then later on, you're going to have something looking like this. Then you need to find where these maximum or minimum, or we call it optimal value, happens. And in order for us to do so easily, we need to factor it, right? So this will be the part 2 video, end of it. And the next actually one is the challenging. But for the challenging, instead of me making the video, I'll just put up the answer key to this. So please take a look at it. But I want you to try it first before you're taking a look at it. For the problem solving, we will do it in the next class. I think it is next week, I think. Anyway, thanks for watching. I'll see you guys in class next time.